Hi everyone, Dr. Vaughn. I'm just making a quick screencast video about the project, this last week project. So this is way easier than doing worked out homework this week. So it's a nice way, and it seems like it's pretty simple, fairly low stress. So I hope that this is helpful to you and gives you time to study for the last test. So anyway, the question was really about these tables, and to be honest with you, these tables don't make a whole lot of sense to me either. In that I'm not sure exactly how they wanted you to fill this out, but it occurs to me that there are lots of different ways we could fill this out. So in the first question, for example, all these are different. There's just different scenarios of basically the same, whether we're drawing with replacement or drawing without replacement, and whether order matters or order doesn't matter. So it's a matter of probabilities that involve combinations or permutations of one kind or another. So it seems to me in this first case, so one person's allowed to win both prizes. Prizes are different, order's important, repetition's allowed. All right, so our sample space, the set of all the possible outcomes in this particular case, we could do it with a letter for who won prize number one and who won prize number two. So for example, an ordered pair AA would mean that Al won prize number one and Al won prize number two. BA would be Bob won prize number one and Al won prize number two, which will be different than AB, which would Al winning prize number one and Bob winning prize number two. So we could sit here and list all of the ordered pairs. The question then is, if I wrote that out on a Word document, I could do A comma A, A comma B, B comma A, etc. and list them all out using these ordered pairs. But how do we put that into the table? Well, you could, add, you'd think that they would add a column here in the beginning where you repeat the labels Al, Bob, Cindy, Diane, and then you can fill in this with those same kind of ordered pairs. So each one of these 16 cells corresponds to one of these ordered pairs where we're designating the row Al, Bob, Cindy, Diane, and then the column, the row is being the first part of the ordered pair, and the column is being the second part of the ordered pair. So I might go up to this table, and let's see. I don't know if this is going to work, but we'll try it. We'll try to do the table properties, see if I can't insert an extra column. No, it doesn't look like I'm able to do that. Yeah, let's try one more thing. There we go. Okay, now right click and I'm going to insert a column to the left. All right, so now I can repeat these labels over here for Al and Bob and Cindy and Diane. And each one of these cells now corresponds to A comma A, the row being the first entry and the column being the second entry, etc. So you could fill this out with all of the 16 different ordered pairs because each cell in this grid would correspond to a different selection of prize winners in this particular case. So it seems to me that in question one, that there's going to be 16 different possible outcomes where repetition is allowed and prizes are different. Now, the other thing that I think you could do is just go with some condition of the 1 and 2. So Al won prize number 1 and Al won prize number 2. So I could, let's just undo this all the way back to the original table that you had here. And I could do something like this. Al won prize number 1 and Al won prize number 2. But I'm not really sure how this would fit into the table in that case. You'd have to sit there and list out all of these different people, and only one person could have a 1, and only one person, maybe the same person, could have the 2. And so you'd put into each cell the different permutations, but you need more rows to your table. So Al having prize 1 and Al having prize 2, nobody else gets a 1 or a 2. And that's one of the options. And another option is Al won prize number 1 and Bob won prize number 2. Another option would be Bob won prize number 1 and Al won prize number 2. And I could keep adding rows to this table until I've gone through every possible, combination, permutation of these names. And then at the end, you're supposed to reflect on whether this is a combination or a permutation. I think in light of what we learned in the first approach that we used here, that you'd need 16 different rows here in order to use this different approach to capture everybody having a 1 and everybody having a 2 in every possible order. So I hope that this has been a little helpful to you. I hope that it calms your nerves a little bit in that there's not necessarily a one right um, way in which to use these tables to express the list of the possible outcomes. What I would ask you to consider is how can you use the table or expand upon the table in order to communicate the possible pairings, the possible outcomes from this probabilistic presentation of the problem in such a way that it would make sense to me. And then if you need to narrate, I'm going to use this table as follows, and I'm going to depict all the possible outcomes by doing such and such. Just go ahead and type that into your response. I'm the only one that's going to be looking at this. So make sure you put your name on the project somewhere and make sure you upload it by Sunday. All right, well, I hope your week is going well. And if I don't talk to you again by one of these screencast videos, it's been a pleasure having you in class. And I wish you all happy holidays and best of luck in the rest of your academic studies at Baker College. Have a great day.